For years, the promise of solid-state batteries has hovered like a mirage, powerful, ultra-safe, and long-lasting, but always 5 years away. That mirage just turned real. Chinese and Japanese battery makers have reportedly achieved a working prototype capable of powering an electric vehicle for more than 1,200 kilometers on a single charge, nearly double today's top EV range. If this holds true, it is not just another step forward for electric cars. It is the beginning of the end for traditional lithium-ion batteries. The leap that changed everything. The key lies in replacing the liquid electrolyte found in current batteries with a solid ceramic or polymer one. This switch eliminates flammable liquid components, dramatically improving safety, while also allowing for denser energy storage, meaning more power, less space. Companies like CATL, Toyota, and EO have quietly been in a race to perfect this design. In mid-2025, CATL claimed to have developed a solid-state hybrid battery with energy density over 500 watt-hours per kilogram, while Toyota showcased a prototype that recharges from 0 to 80% in just 10 minutes. These are not lab demos anymore. They're real systems being prepped for mass production trials in 2026. Why it matters. Solid-state technology could change everything about how we think of energy and mobility. Imagine an EV that drives from Toronto to New York and back, without stopping to charge. Imagine aircraft running on electric propulsion, or smartphones that last for days. It's not just about range, it's about freedom from charging anxiety. Right now, most EV owners still plan their routes around chargers. Solid-state batteries could finally make electric travel feel as effortless as filling up gas, only cleaner, lighter, and safer. Automakers like BMW, Hyundai, and Honda have already signed partnerships with solid-state battery startups, investing billions. Everyone wants a piece of the next lithium revolution. The challenge is still ahead. Of course, no technology revolution comes easy. Solid-state batteries face a massive manufacturing challenge. The materials used, like lithium metal and sulfide electrolytes, are expensive and difficult to produce at scale. Even small impurities can cause short circuits or degraded performance. Then there's the temperature problem. Solid-state batteries perform best in controlled environments, but real-world vehicles face cold winters, hot summers, and rough conditions. The race isn't just about making the chemistry work. It is about making it work cheaply and safely in millions of cars. Experts believe that mass production won't reach global scale until 2027 or 2028, but early adopters in Asia might get the first wave of high-range vehicles sooner. The bigger picture. This isn't just a car story, it's an energy story. Solid-state batteries could reshape the entire renewable ecosystem. They can store solar or wind power far more efficiently than current lithium-ion setups, unlocking new levels of grid stability and off-grid independence. It's the same energy race, but with new rules. Whoever dominates solid-state manufacturing will lead the next decade of electric vehicles, aviation, and clean energy storage. China's CATL has the momentum, but companies like Toyota and QuantumScape are determined to catch up. The result is a new battery cold war, where innovation isn't about size or horsepower, it's about atoms and electrons. The verdict. For the first time, the promise of a 1,200 kilometers electric vehicle isn't fiction, it's engineering. The question is no longer if solid-state batteries will arrive, but how soon they'll change everything we know about mobility and power. This is more than an upgrade. It's the rebirth of the battery, and possibly the moment when electric finally beats everything else in power, safety, and endurance. If you found this video informative, don't forget to like, subscribe, and share. It really helps the channel grow and keeps us bringing you the latest in tech and innovation.